Very good morning, my dear visitors. So, this heat and mass transfer convection, I am going to deal about the internal flow, turbulent flow. Earlier, we had seen the laminar flow. In this session, we are going to see the turbulent flow. So, it will be an opening session for the people who are seeking the internal flow in elaborately. So, we should know, let's recall, we should know the convection mode, Newton's law of cooling, laminar, turbulent is basic, we must know along with what is he H. So now coming to the topics for the discussion, introduction to the internal flow, characteristics of turbulent flow, neutral convection and forced convection, key differences, importance of turbulence and applications, scope for structure. These are the topics for the discussion in this presentation. Now let me see one by one. Introduction to internal flow, which is design thinking based structured explanation. So, which is empathized with the characteristics of the turbulent flow, which is defined at the natural convection, and which is having the connection of convection heat transfer, implement, and prototype. These both are connected in this concept. So, I am deliberating the concept along with the five stages of design thinking. That's why this slide I have shown here for understanding, empathize, define, ideate, and prototype. So, coming to the introduction to the internal flow. The sketch deliberates about the Reynolds number transition range for the laminar for the internal flow 2300 range. For the turbulent, the Reynolds number is around 4000, greater than 4000. For the transition from laminar to turbulent, it falls between 2300 to 4000. The fluid flow inside the pipe happens here is like one. So the key concept are internal flow, Reynolds number, and flow regimes. Fluid flow, laminar flow, and turbulent flow. These are the concept of internal flow. Understanding fluid flow within pipes and ducts. That's why the purpose of this slide I have chosen here. So we see introduction to heat flow. So internal flow, boundary layer, flow area, and turbulent flow. So for the internal flow, fluid motion boundary by solid surface. For the boundary layer, layers of fluid near solid surface. For the flow area, space occupied by the fluid. For the turbulent flow, chaotic fluid motion. Is a graphical representation of the basic internal flow interaction. If we come to the characteristics of turbulent flow, how to understand and manage internal flow. Internal flow or fluid motion within the solid boundaries. So whereas the boundary layer interaction, boundary layers meet falling the flow area. So that's the internal flow and the boundary layer interaction. Coming to the empathize. So buoyancy driven motion. Why is buoyancy driven motion? It's a fluid motion caused by buoyancy force from density gradients. What causes these density differences? Usually temperature variation like hot air rising that creates the boundary layer rise or fall. That is buoyancy force. What can this lead to internal environment? That environment circulation cells where the fluid rotates due to heat sources at the boundaries. So coming to the concept, force convection. So pros and cons of this force convections are pros, higher heat transfer, controlled flow, and efficient cooling is the pros of this force convection. Cons of this force convections are energy consumption, noise pollution, and maintenance needs. These are the pros and cons of the force convection. So here we are going to compare convection type for different heat transfer. Slow moving, fast moving, gravity and temperature is the key parameters. Mechanical power, that is forced fans and blowers, are the fast moving parameters. Natural convection, force convection I compared here for the understanding. Here let me see the assessment questions. Which type of convection is driven specifically by buoyancy force caused by temperature induced density changes? Force convection, natural convection, mechanical convection, and static convection. So expecting your answer, that is natural convection. Which type of convection is driven specifically by buoyancy force caused by temperature induced density changes, so which is B, natural convection. So here, if you think it's a forced convection, there also the buoyancy force is there. The word should be external agents, something like that, which doesn't mean about the density changes. In the study of dynamics of internal flow, turbulent flow, which two specific mechanisms of convections are categorized together. Passive and active convection, natural and forced convection, internal and external convection, laminar and chaotic convection. We already seen that laminar and chaotic. So these are the references we have seen for this preparation. And I thank everyone for listening. Thank you.